If you're new to Linux gaming and always wondered how Windows games work on Linux, people do this, right? When you run applications or games on Linux, there's a lot happening under the hood that you might not realize. In this video, I'm going to explain how Windows games run on Linux. Think of this video as an oversimplified crash course. So, with that being said, let's get into it. Before I start explaining how Windows games work on Linux, I think it's important to understand what computers are. Computers might seem complex, but at the deepest level, they only understand ones and zeros, tiny electrical signals that turn on and off. The CPU, or the brain of the computer, reads these instructions and carries them out. But the CPU doesn't work alone. The operating system, like Windows or Linux, acts as a manager, deciding which programs run, handling memory, and letting software talk to hardware, like your graphics card or keyboard. On Windows, programs come as .exe files. When you open one, Windows sets everything up. It loads the program, finds the libraries it needs, and then the CPU executes it. Games work the same way. They just add extra steps for graphics, sound, and input, using Windows APIs like DirectX for graphics and Xinput for controllers. The catch: Windows software is designed only for Windows. Linux uses different rules, so .exe files can't just run there natively. It's like trying to use the wrong plug in a socket. And this is exactly where Wine and Proton come in. Let's start with Wine first. Wine, which stands for
Wine is not an emulator,
is a free compatibility layer that implements the Windows API on Linux. Still don't get it? Okay, imagine a Windows application on the left and a Linux system on the right. Wine acts like a middleman between the two. When an application launches, it asks for Windows API calls, and Wine translates those calls into something Linux understands. To make it easier to understand, Wine is like a very clever interpreter at the UN. The speaker, who's Windows, talks only in English, which are Windows calls. The interpreter, Wine, instantly converts everything into French, which are Linux system calls, without the speaker realizing they're in a foreign country. Fun fact, Wine was first released in 1993, and it has over 30 years of continuous development. At first, Wine was mainly aimed at running business apps, not games. So while some games worked, others needed heavy manual tweaking, which was unattractive for people who are new to Linux at the time. That's where Proton comes in. Proton is Valve's gaming-focused fork of Wine. It does everything Wine does, but adds tons of gaming-specific improvements. Things like DXVK and VKT3D Proton, which translate DirectX to Vulkan. Then we have eSync, FSync, and NTS Sync, which are just designed to speed up performance, Steam integration, and patches for specific games. So when you run a game with Proton, it's essentially Wine plus everything needed for gaming to just work. Together, Wine and Proton trick Windows applications and games into thinking they are running on Windows when they are not. Now that we know what Wine and Proton do, let's dive a bit deeper. When you run a Windows game on Linux, Wine or Proton sets up a kind of
fake Windows environment.
But sometimes the game expects extra parts of Windows to exist, like specific versions of .NET framework, DirectX components, or Visual C++ redistributables. This is where Winetricks and Protontricks come in. Think of them like toolboxes. If a game says, hey, I need this Windows library to run, Winetricks or Protontricks lets you install that missing piece directly into the game's environment. Now, if you have ever browsed the game files after running it through Wine or Proton, you have probably seen some odd folders. These belong to something called a prefix. A prefix is basically a fake Windows installation stored inside a folder. When you look inside, it looks just like a real Windows setup. There's a C drive, a Windows folder, a program files folder, and even a registry. The cool part, each prefix is self-contained. That means every game gets its own mini Windows. So if something breaks, you don't risk your whole system. You can just delete or reset that one prefix and start afresh. At this point, you might be wondering, okay, if Wine and Proton already exist, why are there so many different versions? The short answer, because not all games behave the same, and different groups maintain their own flavors to fill in the gaps. Here's a breakdown. We have talked about Wine, but basically this is the official version maintained by the Wine project. It's the raw foundation. Then we have Proton. This is Valve's version optimized for gaming with DirectX to Vulkan translation, Steam integration, and tons of patches. Then we have Proton GE, a community build maintained by Glorious Eggro. It often includes the newest fixes for games that don't work on regular Proton yet. This is the go-to if a Steam game refuses to launch. Then we have System Wine. This is the version of Wine you install from your Linux distribution's package manager. It's good for running general Windows software, but usually not gaming optimized. And finally, we have other builds like Lotris Wine, Bottles Runners, Soda, etc. These are special builds with extra libraries, codecs, or experimental patches, often aimed at compatibility outside of Steam. So why does this matter? Because Linux gaming isn't about hoping one magic version works. If a game won't launch on a regular Proton, you can try Proton GE or another build, and suddenly it works perfectly. That flexibility is the secret sauce that makes Linux gaming viable today. And that's pretty much it. Honestly, I'm just glad Linux gaming has come this far. Without Wine, Valve, and the open source developers who have worked on all of this, gaming on Linux simply wouldn't exist today. And I think it's something we shouldn't take for granted. If you enjoyed this video, give it a thumbs up and comment down below if I missed anything important. Without further ado, it's your boy Jury, and I'll see you in the next video. Take care.